In this video, I would like to talk about the educational and training materials that we have compiled on the origin of the aroma of each component adopted as the reference standards for the flavor wheel for Honkaku Shochu and Awamori. First of all, I would like to explain how to read the following slides. The title of the slide has a 3-digit number as the code for the reference standard as well as the name of the compound. Basically, please check the name of the component by looking at this part. Below that is the name of the substance in English, the Chemical Abstract Service (CAS) number assigned to each compound, and the molecular weight. Although you may not need or use this information very often, it can be used when looking up the type of reagent. Below that is the structural formula that shows the chemical bonds between the atoms, and on the right side is an illustrative representation of the aroma and the detection threshold value that I mentioned earlier. If the concentration of the component in the alcohol is higher than this value, it means that it has a certain degree of contribution to the aroma. Also, the detection threshold value at this part is the value based on a 25% ethanol solution. If we move a bit down, you'll see the sensory attribute terms associated with this reference standard that was listed in the flavor wheel for Honkaku Shochu and Awamori that I showed you earlier. And at the bottom of the slide is a section that would list details such as the aroma characteristics of the component, its origin, such as how it's produced in the alcohol manufacturing process, and maybe the category in which the component is under. Next, I'll talk about the compounds in order on the flavor wheel. First up, from the fruity aroma group is isoamyl acetate. The associated term is banana. It has a sweet aroma reminiscent of bananas and is mainly produced by yeast during fermentation. There have been reports that using yeasts with increased ability to produce isoamyl alcohol results in higher production of sake. Next up is ethyl caproate, and the associated term is apple. It has a sweet aroma reminiscent of apples and is also mainly produced by yeast during fermentation. In addition to highly productive yeast, it is also abundant in Honkaku Shochu, made with ginjo sake leaves. Next is ethyl isobutyrate, and its associated term is pineapple. This is also produced by yeast during fermentation and is known to increase in content in sake during storage. Last in the fruity aroma group is ethyl acetate. The associated terms are the names of the component, such as esters or ethyl acetate. In excessive concentrations, it has been described as smelling like nail polish remover or glue, and is also known as the aroma for overripe melons. It is mainly produced by yeast during fermentation and is a component found not only in Honkaku Shochu and Awamori, but also other spirits. Next is the floral group. The very first one is rose oxide, which is characterized by a sweet and gorgeous floral aroma. Studies have reported that rose oxide is produced during the production of sweet potato shochu when the citronellol in the fermentation mash is acid catalyzed converted during the fermentation process, in which the chemical conversion is further accelerated and more rose oxide is produced during the distillation process. Next is the beta-phenethyl alcohol, and its associated term is rose. It has a pleasant rose aroma and is reported to be produced from the metabolism of phenylalanine by yeast as well as dependent on the amino acid composition and total nitrogen source in the fermentation mash. Next up is linalool, and the associated term is lavender. It is characterized by the aroma of lavender and lily-of-the-valley blossoms. Studies have reported that koji mold enzymes break down monoterpene glycosides in sweet potatoes during the production of sweet potato shochu, which are then converted into linalool by the acid and heat during distillation. Next is beta-ionin, and the associated term is fragrant olive that was given by experts in the recognition experiment earlier. It has an aroma reminiscent of violets and is known to be produced in large quantities when orange sweet potatoes are used in the production of sweet potato shochu. Studies have also suggested that beta-ionin is related to beta-carotene. The last in the floral group is beta-damascenone, and its associated terms are honey and sweet flowers. It is categorized by the aroma of roses and honey, as well as the sweet scent of black tea and apple compote, which is also the characteristic aroma of sweet potato shochu. Most of the free beta-damascenone is said to be generated during the latter half of the distillation process. Now I'll move on to the sweet aroma group. First up is vanillin, which I'd mentioned earlier in the first example. It has a sweet aroma unique to vanilla and is the main aromatic component of vanilla beans. It is added to alcoholic beverages when storing them in barrels and is also known to be produced in aged sake made by storing awamori. The second one is sotolon, and its associated term is caramel. It is characterized by the sweet aroma of caramel, burnt sugar, and maple syrup, but some people find it spicy in high concentrations. It is known to be generated by storing awamori in earthenware pots, and studies have suggested that it is involved in the aroma of aged sake. The third one is whiskey lactone. The associated term is coconut, and it has a characteristic sweet aroma reminiscent of coconut. Like vanillin, it is one of the aromas imparted by storage in barrels. The next group is the roast smoky group. The first compound that I'd like to introduce is 2-furan-methanethiol, and the associated term is coffee or roast. It is characterized by a roast aroma reminiscent of coffee, but has a pungent burnt aroma in high concentrations. Studies have reported that it is usually generated during the heating process and could be transferred from roasted raw ingredients as well. Next up is 2-ethyl-3,5-dimethylpyrazine. It also goes by cocopyrazine, and its associated terms are nutty and roast. Like 2-furan-methanethiol, it is known to be generated during the heating process and is found in relatively abundant amounts in barley shochu and brown sugar shochu. Next up is furfural, and the associated term is smoky. It is characterized by a smoky and sweet aroma. Furfural has been said to be generated when sugars are heated under low pH conditions by citric acid during distillation, and are known to be present in large amounts in the tail fractions of distillation. Next up is 4-vinyl guaiacol, and the associated term is smoked. It is characterized by a thick aroma reminiscent of smoked food. Studies have reported that it is released from the decarboxylation of ferulic acid derived from raw ingredients by enzymes in shochu koji mold, and that it is also generated by heating during the distillation process. The last compound in the roast smoky group is guaiacol. The associated term is medicinal and is characterized by the chemical-like scent characteristic of phenolic compounds and the scent of disinfectants. It is known to be found in relatively abundant amounts in sweet potato shochu and mainly in peat smoke in whiskey. The next group is sulfides. First up is S-methyl-thioacetate. The associated term is sulfide and has a characteristic odor of sulfur-based compounds reminiscent of eggs. Studies have reported that methanethiol and methionine are generated by yeast in beer. The second one is dimethyl trisulfide. The associated term is Japanese pickles, and it has an aroma reminiscent of Japanese pickles such as pickled vegetables and a scent of sulfides. Some also believe that sulfur-containing amino acids in fermentation mash are involved in the generation of dimethyl trisulfide and is known to be found in relatively large amounts in awamori. Now, I'll move on to the acid and dairy products group. First up is acetic acid. The associated term is sharp acid, and it is characterized by a pungent odor of vinegar. Most know that it is mainly generated by yeast. Especially in the production of brown sugar shochu, the amount of acetic acid generated tends to increase in light of the high temperatures applied in the fermentation mash, as well as the high sugar concentrations. The second one is butyric acid. The associated term is cheese, and it is characterized by the aroma of dairy products such as cheese and butter. It is known to be generated when fermentation mash is contaminated with microorganisms. The last one of this group is diacetyl. The associated term is yogurt, which is characterized by a sweet yogurt-like aroma. When purple sweet potatoes are used in distillation, it is thought that anthocyanins accumulate because the metabolism of diacetyl is suppressed by yeast. It is also assumed that diacetyl is generated from contamination with lactic acid bacteria and so on. The next group is herbal and solvent. First up is hexanol, and the associated term is herbal. It is characterized by a green herbal aroma of grass and soybeans and may smell rancid in high concentrations. Studies have reported that it is mainly produced by the decomposition of long-chain fatty acids such as linoleic acid. Next up is acetaldehyde. Associated terms include names of substances such as aldehydes and herbal, and is characterized by a light aroma reminiscent of trees, grass, and green apples. Studies have reported two pathways of its origin. One is that it is generated by yeast from amino acids, and the other is that it is generated from the thermal decomposition of amino acids during distillation. It is also known that it is mainly contained in large amounts in the head distillate fraction of the distillation process. Next up is isovaleraldehyde, and the associated terms are stuffy smell and solvent. It is categorized by a pungent yet sweet burnt aroma and is sometimes described as roast or chocolatey. Studies have reported that it is generally from leucine by yeast metabolism during fermentation, and it is also thought to be produced by Strecker degradation during heating during distillation. Next up is isoamyl alcohol. The associated terms are ink, solvent, or alcohol. It is characterized by a scent similar to higher alcohols or ink. It is known to be generated from leucine metabolism by yeast and is thought to depend on the amino acid composition and total amount of nitrogen sources in the fermentation mash. I will now move on to the last group, oily mushroom, and introduce the components under this group. First up is caprylic acid, and its associated terms are oily and resin. It is characterized by a slightly heavy odor reminiscent of oil and resin. It is an intermediate compound generated in the fatty acid synthesis pathway of yeast. It is also known that the active proliferation of yeast and that the ratio of nitrogen to carbon in the growth environment affects the amount produced. The second one is ethyl laurate. The associated terms are soapy or oily, and it has a slightly heavy odor reminiscent of these items. It is known to be generated when lipids derived from raw ingredients are broken down by enzymes and combined with ethanol. Because it is also generated during the aging process, ethyl laurate is present in abundant amounts in aged sake of Awamori. The third one is 1-octane-3-ol. The associated term is mushroom and has a characteristic aroma reminiscent of mushrooms such as matsutake and also goes by mushroom alcohol. A component originating from koji mold, studies have reported that it is mainly generated in black koji mold. It has therefore been found that Awamori, which only uses black koji for fermentation, contains especially high amounts of 1-octane-3-ol. The very last component is 2,4,6-trichloranisol. The associated term is moldy, an odor reminiscent of mold, and is also known to be the cause of the cork odor in wine. It is a type of transferred aroma in origin. It is known that the precursor of 2,4,6-trichloranisol is generated when chlorine-based disinfectants are used on wooden utensils in a manufacturing facility, which is then converted into TCA by mold, so care must be taken. I have given a brief introduction of the 30 reference standards and their origins, and this will conclude my presentation. We hope that the reference standards and the flavor wheel, as well as the explanation materials for those, will come in useful for those who are going to be involved in the evaluation of Honkaku Shochu and Awamori.